Hello students, how are you all? Okay, hope you all are fine. Okay, dear students, today we are going to start a new chapter. The chapter name is Forces and Fluids. Okay, Forces and Fluids. Okay, yes. So, students, this is a very interesting chapter in physics. Okay, so based on various principles that we see here, we can find a large number of applications in our daily life. And this chapter deals with the um, um, various types of forces which are acted upon our body by the liquid or gas in which it is kept. Okay, and they are one term is buoyancy. Okay, in this chapter we discuss various topics like buoyancy, then Archimedes principle, then flotation, then relative density, hydrometer and lactometer, then Pascal's law, then capillarity, and finally viscous force. Okay, and in this class we will be discussing on buoyancy and Archimedes principle. Okay, so first of all, buoyancy. Okay, yes. So what is buoyancy? Buoyancy is that when a body is immersed completely or partially in a fluid, then the fluid will exert an upward force on the body, and this force is known as buoyancy. Okay, so what is buoyancy? When a body is immersed completely or partially in a fluid, then the fluid exerts an upward force on the body, and this force is known as buoyancy. Okay, now, in order to understand more about the practical applications of buoyancy, let us discuss some of the questions. Okay, the question is that why does a ship remain afloat on water? Is it due to the same reason that a razor blade also floats on water? But then, why is it not possible for all substance to float on water? These questions will be better answered once we learn more about the concept of buoyancy. So, now let us do an activity which support our study in this regard. Okay, yeah. So for that, what you have to do is take water in a bowl like this. Okay, now onto this place a tightly closed empty plastic bottle like this. Okay, now I am going to place it. You have to observe carefully what happens. Okay, yes, have you observed what happened? Yeah, bottle floats on water surface. Okay, so that's the first observation. Now, after this, using your hand, try to immerse the plastic bottle to the bottom of the bowl. Okay, so for that, don't you have to exert a force now? Yes, so now I am exerting force to immerse this bottle down, right? So, why is it so? why I have to um, what use force, exert force for immersing this plastic bottle? It is because water exerts an upward force. Okay, so now after this, what you have to do is just take off your hand from the bottle after it has been immersed into the water like this. Okay, so observe carefully what happens. Yes, what do you observe? Yes, bottle rises to the surface of water, isn't it? Okay, so why does it rise to the surface of water? Yes, because water exerts an upward force on the bottle and this force which brings to the surface of water. Okay, now let us consider another situation in which a stone in water is lifted. Can you guess what happens? When a stone in water is lifted, its weight appears diminished when compared to that in air. What can be the reason for that? It is because the water exerts an upward force on a stone that is placed in it, and this force is a buoyancy, and it is exerted not only by the liquid but also by gases. So the liquids and gases together are generally called as fluids. Okay, so now I shall give you an assignment that is related to the topic that we have discussed. Okay, that is, can you tabulate some situations in your daily life where this buoyant forces are experienced in liquids and gases? Okay, so please tabulate it. Okay, students, I'm sure that your answers will be like this. First of all, we can say example as a hydrogen filled balloon that rises in the air, right? Then secondly, we can say the ship floats on the surface of water. Then we can say yes, submarines that work by controlling the upthrust of water. Then we can say while drawing water from well. Weightlessness is felt when the bucket is under water level. Then finally, yes, we can say when you go for boating and all, you are advised to wear life jackets, right? You know what's the reason behind that? Life jackets will float on the surface of water because of this buoyancy. And that is the reason why you are advised to wear life jackets. Okay. Okay, now we are just moving on to measurement of buoyancy. That is how buoyancy can be measured. Okay. Okay. So for this, we can do an experiment. Okay. Take a piece of stone. Okay. Okay. Like this, you can take a piece of stone and find out the weight in air using a spring balance. Okay, this is a spring balance that is calibrated in Newton. Now, you can find out the weight of the stone by hanging like this. Okay, okay, like this. You can by using the spring balance, you can measure the weight of this stone. Okay. Now, what you have to do is, after this, find the weight of the stone when that it is immersed in water. Okay. So, by taking a container containing water, and you can immerse the stone in the container, and by that you will be able to measure the weight of the stone, that is when it is immersed in water. Okay, and after that you have to record the data in a table. Okay, so this is a case when we do that experiment. Okay, before immersing the stone into the water, that is initially when taking the measuring the weight, you will get the measurement at this range, and after immersing the stone in the water, you will get the measurement range at this level. That means the weight has decreased, reduced. Okay, so what will be the observation? Yes, the stone loses weight in water. Okay, so what can be the conclusion? Buoyancy is the same as the loss of weight that experience in water. That is, in order to calculate the buoyancy that is experienced by a substance that is immersed in a fluid, it is enough to find out the loss of weight of substance in that fluid. That means the buoyant force of liquid is equal to loss of weight of substance. Okay. Now, next we are moving on to the factors that influence buoyancy. There are two factors that influence buoyancy. First is the density of the liquid, and second is the volume of the body. Okay, so let's discuss in detail about two factors. First of all, density of liquid. Okay, so for that we are going to do an experiment. In this experiment, we'll take water, kerosene and saline water, which are kept in 3 separate beakers like this. Okay. Now, what you have to do is find out the buoyancy of these liquids. Okay, which is exerted on a piece of stone and tabulate that results. Okay. Then the question is that in which liquid did the stone experience the maximum buoyancy? The stone experienced maximum buoyancy in saline water. Okay. Now, next, in which liquid did the stone experience the least buoyancy? Is the density of that liquid higher or lower than that of other liquids? The stone experiences least buoyancy in kerosene. So, the density of kerosene is lower than that of other liquids. That's a meaning. Okay. If so, is there any relation between a liquid's density and buoyancy? Density of liquid is a factor that influences the buoyancy of the body in that liquid. As the density of the liquid increases, then the buoyancy also increases. Okay. Now, let's move on to the second factor, that is influence on of volume of the body on buoyancy. Okay. In this also, let us understand an activity which shows the calculation of buoyancy that is exerted by the water on two blocks of weight, that is one of copper and the other of iron. Okay. Then the buoyancy that is experienced by each block can be seen as different. The buoyancy that is exerted by water on the copper block is greater, and on iron block it is found to be less. The mass and the weight of the copper and the iron blocks are the same, but the volume are different. Copper block has greater volume and the buoyancy experienced by the copper block is greater, whereas iron block has less volume and the buoyancy experienced by the iron block is less. Okay. Okay. Now we move on to a very important principle, that is Archimedes principle. Okay. So this principle states that when an object is immersed partially or completely in a liquid, the buoyancy experienced by it will be equal to the weight of the liquid that is displaced by it. Okay, this can be explained through an experiment in which the buoyancy of a piece of stone in water is determined simultaneously using an overflowing jar. Find out the volume of water. Okay, this is an experiment. Okay, we are measuring the weight of the immersed stone, and simultaneously we are measuring the weight of the that displaced water. Okay, and so find out the weight of the water that is overflowed using a spring balance. Okay, and tabulate the results in a table. So and it is found to be same. Okay, the loss of weight of stored in water is the same as that of the weight of water that is overflowed. So this experiment shows that the buoyancy that is experienced by an object and a liquid will be equal to the weight of the liquid that is displaced by it, and this is known as Archimedes principle. Okay, so that's about Archimedes principle. Now let us know the interesting story behind the evolution of this Archimedes principle. Okay? Yes. So, Archimedes was born in 287 BC at a port city in Italy, and he lived during the rule of Herod. Okay. So this King Herod commissioned a goldsmith to fabricate a crown for him. Okay. This Archimedes was famous even at that time itself. So King Herod commanded this Archimedes to find out whether there was any impurity in his crown. So Archimedes was very confused how to do this. He knew that the density of the pure gold could be calculated by dividing the mass of the gold bar by its volume. But his confusion was how to calculate the volume without damaging the crown. So when he, after that, he left that place, then he went to home, and when he stepped into his bath, he could see water overflowing. So this made him realize that he could calculate the volume of an object by finding the volume of the water that is displaced by it. So by finding the density and the volume of the gold, he could prove that the crown contained impurities. Okay, so that was an interesting story behind that. Okay, so students, when we conclude, there are different types of forces in fluids such as buoyancy, flotation, capillarity, and viscosity. The upward force that is experienced by a body which is partly or fully immersed in a liquid, it is buoyancy. Buoyancy depends upon density of liquid, then volume of body and the mass of liquid that is displaced by the body. Then, according to Archimedes' principle, the buoyancy that is experienced by the body, which is partly or fully immersed in a liquid, it is equal to the weight of the fluid that is displaced by it. And finally, there are many excellent applications for the Archimedes principle. Okay, students, I hope that the topic is clear. So, in the coming classes, we will be discussing more types of forces. Okay, so thank you, students. Thank you.